Here's another one straight out of your textbook. This is on page 374, number 6. So this one's talking about a painting being sold at Sotheby's auction in New York City for $44.4 million. That was in 2014. The painting had previously sold for $1 million in 1994. Assuming that the value of A of the painting has grown exponentially, find the value of K and determine the exponential growth function. Assuming A sub 0 is 1, and T is the number of years since 1994. So the key here is to read the problem carefully and pull out the information. So they're kind of giving you a hint in part A. They're telling you the initial amount is $1 million, and that was in 1994. Time is always your independent variable. Time is always X. And then the other year that they gave you was 2014, and the painting sold for $44.4 million. Okay, so we're being asked in part A to find the value of K. They want the growth rate. Okay, the first problem was pretty easy because they gave us the growth rate. But this one and most of the problems after this, they're not being that nice to you. So remember, this is pretty much our only equation to pick from. Okay, we got to use that equation. And we're being asked to figure out what K is. So we got to fill some numbers into this equation. So in this case, P is not a population. It's not how many rabbits. It's money. Okay. So the ending value was 44.4. The starting value was $1 million. We do not know K. And the amount of time that passed is 20 years. From 1994 to 2014. So remember, T is your value of time. So all you got to do is solve this, okay? You just have to solve this equation. I'm going to divide by 1. Well, that doesn't change anything. 44.4 equals E to the 20K. The next step is to take the ln of both sides. Take the log of both sides. That's going to give you a chance to use the power rule. And you'll see most of these problems follow the same general procedure. You divide, you take the ln, use the power rule, you divide again. Ln of E is 1, so you don't need that. So if you take ln of 44.4 divided by 20, you should get your value for K. I got 0.18966. I would caution you against rounding off too much. Okay, if you round off too much here in part A, your answers later on may be too far off. I'll just warn you of that. So 3 or 4, or in this case I went up to 5 decimal places. So part B, estimate the value of the painting in 2019. So they're asking us to find the ending value. Remember, it started with $1 million in 1994. We know what K is now. We're just filling stuff into the formula. But now we're talking about 2019. So 2019 is 25 years after 1994. So this 25 came from 2014 minus 1994. Okay, or 2019 minus 1994. So anyway, you just got to plug that into your calculator. 0.18966 times 25. So the answer for that is about $114 million. That's assuming it keeps growing at that same pace. Part C, they're asking what is the doubling time of the value? Well, again, the doubling time is asking you how much time does it take to double. Well, remember it started at 1 million, so double of that is 2. We now know what the value of K is. What is it? 189. I got that wrong. 18966, and they're asking us to find how long it takes to be worth double. So again, the process is the same. Just divide by 1. We get 2 equals e to the 0.18966t. We take the ln of both sides. Use the power rule. All right, so remember, ln of e is 1. Okay, you don't need that. Divide by 0.18966 should give you the value of t. So ln of 2 divided by 0.18966 gives us about 3.65 years. Now that's 3.65 years after 1994, whenever we started counting. Okay, the textbook rounds that off to 3.7 years, but close enough for me. Okay, part D, it says after how long will the value of the painting be worth 280 million, assuming there's no change in the growth rate. Well, they're asking us to put a 280 in for the ending value. Okay, so as you may notice here, this is the same exact type of equation as the last couple calculations. We're going to divide by 1. That gives us 280 equals e to the 0.18966t. You take the ln of both sides. Use the power rule. This goes away. It's a 1, remember. Divide by 0.18966. So ln of 280, make sure I close a parenthesis there, gives me about 29.7 years before it's worth 280 million.